Hello everyone. Today we are going to study about 8051 microcontroller architecture. So at first let's get into the basic of a microcontroller. So what is a microcontroller? So and why do you need to learn a microprocessor or microcontroller? So every system, the core of the system is actually a microprocessor or microcomputer, what we say. So any system you take nowadays, like it could be a communication or a digital entertainment or maybe some portable gadget or medical equipment you take, everything consists of a controller or a processor. So it is a core unit where the program is stored to perform certain operation. So the user application supposed to run in those microprocessors. And what are the tools that we need uh, inside a microcontroller or a processor? So the major component inside a controller or a processor is a CPU, which is a central processing unit, and an IO port, and a bus address and data bus, and a memory is important. Then rest all are the peripherals, which are so basic materials or the components inside a processor is a central processing unit, the IO bus, and the address and data bus, and a memory. This is a main component, and rest of are optional component, which depending on the necessity they will put. Anyhow, these timer, interrupt, serial ports, parallel port, and there are still more advanced controller where there are communication ports, the wireless communication modules or ADC modules. So these things are an optional. Now, a typical microprocessor system will have, as I said, a CPU, ROM, RAM, and IO port, timer, and serial. So let's move on quickly to a microcontroller unit. What it has? A microcontroller is a single chip solution where a processor is supposed to have the RAM, ROM externally. So the data will be a huge for a processor based system, whereas the data processing is minimal in case of a controller system. So a controller can be imagined as a single chip solution for any computing system where we'll be having a CPU, RAM and ROM and IO ports, timers, and so and so. So there are so many controllers in the market, Motorola, Intel, Zigbee, PIC, AVR. As you can see, numerous number of controllers are there. So all these contains different specifications in terms of the RAM, ROM, port selection, so timer. So basically, selecting a controller is actually a challenging issue. So to conclude it in a simpler way, what is the difference between a processor and a microcontroller? So as I mentioned, the processor usually used in a place where the huge data processing is there, and a controller is used whereas minimal number of data processing operation is required, and there's a very not much complicated system. A microprocessor will be having a CPU standalone and RAM, ROM, timer separate. Everything is separate because it is basically having the strong, powerful processing unit. Whereas a controller will not be so complicated. Everything is on a single chip, where a processor is not. You take an example of a computer or a desktop system or a laptop. It basically consists. It is made up of a processor, not a controller. If you think of a calculator, it is made up of a controller, or we think of a BP monitoring unit, a small gadget, a smartwatch, or a fitness band, or maybe some digital clock. You take all these are based on microcontroller, where you don't have to worry about a large, data processing operations. So basically, all are in a single chip. Whereas if you take a processor, you see you need to connect an external hard disk, external CD drive, external memory, and external display card. All these things has to be separately connected, where a processor alone manages everything in a motherboard. So that is a meaning it operates, all the peripherals separately in a section wise. So So I can choose the amount of the ROM, RAM, and IO ports required in a processor. That's the specification. You can have your laptop with different configuration. That is the beauty of a microprocessor based system, whereas microcontroller unit cannot have it. So the best example, I can even take an example of uh, calculator, or you can even take an advanced gadgets like a smartphone. To some extent I can call it as it is, advanced microcontroller based system, where things are fixed, whereas you don't have much of peripheral interconnect for controller systems there. So I need to have, I have a limited number of memory there, whereas processor is not like that. I can extend the memory. And the microprocessor based system is inexpensive, whereas controller is not that expensive, and is versatile and not expensive and general purpose. Generally microprocessors are all general purpose, where it will basically run on an operating system. Whereas controller is not like that. It is basically with runs on a custom programming, like a firmware. We call a small bunch of code is flashed into the memory, and we do some specific job. So that is a microcontroller. So microcontrollers for an embedded system. So the embedded system is a field where the controller plays its role. You can take an example of home appliances, or maybe in office, or maybe in automobile. A large number of applications can be found for this microcontrollers in an embedded systems. So we'll see how what is the design constraints that are actually matters when you choose a microcontroller. As I mentioned earlier, there are a lot many microcontrollers in the market, varies from 8-bit to 32-bit, different data bits size, as well as different IO port requirement features. So the it basically depends on the type of application that we want to build. So so these are the factors that actually comes into picture when you make a design, or when you choose a controller for a particular application. So if you want to do a application in where the speed is critical point, then you need to consider the speed of operation, the clock speed, how much you can negotiate in terms of the clock. The packaging, I mean, packaging in the size, the dimension of the chip. Generally, there are dip package, there are quad package, there are SMD packages. So these packages comes when to picture when you are really worried about the size of the chip. The power consumption, as again, depends on application. In the medical field, when a fitness band, we want power to be consumed less actually, because we want that device to last longer when where the no power is available. Okay, so the RAM and ROM required on a chip. So what is the size of the firmware that you want to flash it onto the board? So there is a separate firmware required for a gadget like you think what is there in a fitness band, the amount of the firmware required to take a BP reading. And the another case, you may have a printer. So printer, it needs to operate lot many hardware devices, as well as motors, stepper motors, and servo motors, and so a lot of power is required. So the consumption is more there and consumption is less. So the amount of the RAM and ROM required varies. So all these adds up to the cost. Similarly, the IO pin requirement, how many IO lines you need to handle the device, and the kind of upgradation. If there is a change required in the product, then can it be upgraded straight away without changing any hardware? And the main thing is cost per unit. So this is ultimately based on all the above factors, the cost will come into picture. So wherever you can compromise the features, or you can consider it, so the whole cost of the system can be figured out. So that is the basic criteria for choosing a microcontroller. It's very important. So as you when you take up some project, and seriously on a commercial basis, this may be an important factor. So there are not many controllers available, and development tools is again one of the issues. So you need to find a proper development tool. Whether do you have a library for building an application, because lot many tools, lot many features of the controller has to be used in the project. So you need a the support, the library. Otherwise, everything has to be written from the scratch. So there are famous 8051. I mean, let's take an example of this 8051. So 8051 core is used in most of the companies, and they have produced their own chipsets. So these are the companies like Intel, Atmel, Philips. All these companies have produced 8051 core, and they are using it, right? I mean, in the market. So let's get into some structure, the basic structure of an 8051 microcontroller. So we will start with the 8051 control feature and pin diagram and a block diagram. So coming to the 8051 microcontroller, so it is an 8-bit processor, and it is first introduced by Intel. And coming to the other subsets of 8051, there are 8052, 8031, and now there are lot many companies are using the same core. So initially it was actually 4 kilobyte ROM which was there in 8051. 8052 has 8 kilobyte, and 8031 0 kilobyte. Because it is external program memory, it uses external program memory. You can have up to 64 kilobyte actually in 8031, whereas in 8051 and 52 you can, it is a fixed internal memory that we can use. RAM, timers, IO ports, serial port, interrupts, all are listed. So basically it's a minimum configuration that we can have. And still lower values could be possible if you choose a different core, or maybe different vendors who provided 8051 core. So basically, if you want me to highlight the features, what is this 8051 microcontroller is? So feature is something, the main highlight of this processor. The first highlight is it supports 64 kilobyte of program memory address space. The 8051, the chip what I'm talking, it supports 4 kilobyte, the original 8051 4 kilobyte, whereas this is a general core feature that I'm talking, not about a particular chip. It may be a core feature. So this could be applicable even for your 8051 Intel basic chip. So 64 kilobyte program space, 64 kilobyte data memory space, 4 kilobyte of on chip memory. So the 64 kilobyte of memory space and 4 kilobyte, you mean to say that I can have a separate 64 kilobyte of memory in the external. Okay, internally if you choose, it is only 4 kilobyte, and 128 bytes of the RAM, that is the data RAM internal, and 32 bidirectional IO ports are there, and two 16-bit timers are there, and full duplex UART is there, serial communication, then interrupt sources are there, and on-chip clock oscillators. So this is the basic fundamental features of 8051. Moving on to next, this is a typical DIP package. You know what I'm talking about, a package. This is a DIP package where each lead between these two leads distance is around 2.5 mm or zero point 0.2 inches. Okay, that is the pin gap. So it's a 40 pin device, as you can see here. So these are the ports, and you can literally see most of the features like 4 ports. I said IO lines. You see P1.0 is the first line, and 1.1 is the second line of that port 1. Similarly till port 1.7, that is port 1. Then we have this reset signal for the processor. Then you have the port 3 here. This is port 3, and I can see here something in the bracket. Okay, this indicates that it is dual operation. See, some I can use it as a port, or I can even use it as some of the special features. When I'm using timer, I will use it as a timer input. When I'm going to interrupt, I can use this pin has to be used as interrupt. When I'm going to use serial communication, this pin works as a serial communication ports. Okay, that's the meaning. So they are multiplexed. Both the operations are multiplexed, and these are the two crystal inputs, and finally a ground. So 20 pin identification we already made. Rest of the 20 pins are here on the other side, starting from port 2 till P2.7 is a port. Then actually you see these three signals, what you can see here: PSC, program enable, and ALE. This is the user for a memory interface. Okay, then you have port 0, and there is a VCC, and these AD0 to AD7 and AD8 to AD15, all these things, A0, A8 to A15, all these things are used when you use external program and data memory. The address and data bus are generated through these two ports. So that's a brief description about the spin of 8051. Moving on to the next, the most important aspect is a block diagram. So interrupts. CPU is a main block of 8051 microcontroller. As you can see, the data line here, it is this is the data line, which is a common data line which connects with all the blocks here. So it has the CPU, and next is the RAM. See, as you can see, this is a ROM location where 4 kilobyte program memory that I am addressing. Then you have this 128 byte 128 byte RAM. Okay, and you have timers, and there is a serial port here. Then there is an IO port here, and there is a bus control unit which controls the signals for all these bus movement, and then finally an oscillator, and here is an interrupt. So see, this basically whatever I have discussed in the features, all the blocks are connected to a CPU. So see, every block is connected to CPU because CPU is a main central processing unit where the signals to rest of the blocks will go. So just to give some few highlights here, as I mentioned, the program usually written in this ROM. Okay, whatever firmware we talk about, this will be usually flashed into this ROM, and it's a read-only memory. It is one-time programmable. You cannot erase it further. So if you want to go for a further, you need to go for a flash type of memory. Okay, this is a RAM. This contains all the register definitions for the like bank registers and all. Most of the registers are put up here in the RAM. And apart from that, there is one more called a special function register. So that also will be put up here itself. Okay, that becomes 256 byte space. Another 128 byte will add. Then you have here timers and a serial communication. These are the four ports that we see in that pin description. All that P1 not to P3, all these are the ports which came out of the chip. Then the crystal pin connection also shown in same crystal connection. So this is the basic architecture or a block diagram of 8051 microcontroller. Then this block diagram actually taken from a data sheet. So if you download the data sheet of 8051 original microcontroller, the internal structure is put up in a very detailed and still more divided further into different blocks. How exactly, this is a rough, the previous one is a rough estimation how things are connected, whereas this block diagram will give you the detailed connection of the block. So moving on to further, we will get into the memory organization. How exactly the memory space in 8051 is organized. So with this architecture, I'll conclude it here. So just to summarize it, the features, the architecture of this 8051 microcontroller can be used to understand the memory space of the internal RAM. So next what we cover is actually more about the internal RAM, how exactly the structure of these registers are put up in the RAM. So that's all about the architecture of 8051 microcontroller.